Hi, my name is Chadwick. I'm a DaVinci Resolve Master Trainer based here in New York, and this is part 5 of a 5-part masterclass free course here on YouTube on how to do inpainting using the Fusion page of DaVinci Resolve 21 to remove an object, to remove a foreground sticker off the side of a Bronco. Now, in the past lessons, we've learned stabilization using frequency separation. We've learned the smear tool and how great that can be to procedurally remove an object on stabilized footage. We've talked about using the clean plate tool as an option, as well as blur and divide. But this is the lesson that sort of pulls it all together so that things are believable. It's all about texture. So we're going to be using frequency separation in multiple ways to just add texture back onto it, make it believable, and to also just to add the original grain back wherever possible as well. In the past, we've done 3 different methods to sort of work on this diffuse of removing the original logo. So I'm working off of the planar tracked version, so it's stabilized. We get our lighting changes across every frame. We just need to pick one of these at this point. I'm going to choose the one that we had done that did a smearing technique with a directional blur to clean things up. So we'll just move forward from there. So if you missed that was episode 1 and episode 2. We're picking up after episode 2, and you could ignore those others. The first thing I need to think about before doing frequency separation is I need to cut this patch out back over the original stabilized version of the footage because I need to just exclude the area we worked on. Best way to do that in Fusion is a brightness contrast node with a mask. So brightness contrast, BC. There's lots of ways to do everything, right? But this is the way I'm going to do that. I need to see actually where I'm drawing my mask, so I'm going to my reference frame from the steady planar track at frame 1122. And I'm going to grab a B-spline tool from up here, and I'm just going to click around the area we want to patch over the original. That's kind of the idea, is we're trying to preserve original plate pixels as much as possible, stuff you cannot do with AI. Now that it's closed up, the next thing I always try to remind people to do if they're working with stabilized versions of stuff is just to right-click over on the inspector and say remove B-spline to Polyline so we don't accidentally change this and animate over time if we didn't mean to, which, I mean, you can use multi-frame mode anyways. That's just going to save you some headache. Now, the other thing is I want to set some softness to this. You can use soft edge that's in the inspector. That's a Gaussian blur that blurs inward and outward at the same time. If I blur inward, you're going to start revealing the original source, so I don't want that. What I want to do is actually just expand outwards, and you can do that with what's called a double polyline. And there's sort of an order of operations that I like to follow when I use double polylines. Is first click double poly, so it's this DD right up there in the viewer. Select everything, hold O, and drag with your cursor to the left there, and you'll see this is going to add some softness. So that is our patch that we'll be adding back over the top. Now I'm just going to plug this into the brightness contrast node, and that should set the resolution. The resolution otherwise was set to the full frame. Now brightness contrast node is not doing anything until I go to settings and say multiply by mask. And now we have our cutout patch of just the color diffuse layer, which we merge back over the original stabilized copy of the footage. We'll do that with a merge node. So just grab a merge, take the stabilized footage as the background, the patch is our foreground, and there you go, Bob's your uncle. Now we're going to take this image and frequency separate it so we can paint in texture. Because one thing that may not be obvious unless you take your gain and gamma sliders, that's holding your LUT viewer option there, dragging your gamma down, maybe expand your contrast a little bit, is the area that we worked on has just blurry lines. See how there's still some texture there? I want to grab some of these original mud splatters and stick them over the top, and that's what frequency separation can allow us to do. I can take and clone texture only on top of this diffused color. So the way that works is a blur and a subtract or a divide. You could pick your path. We did divide earlier for doing the tracking. Let's do subtraction for this method. So I've got a blur tool, that's part of the recipe. I need a channel booleans to do division. And I'll take this output, so that's our merge from that's our patch, that's our original stabilized version. We're taking a blur and we're going also into channel booleans and we're taking the blurred copy into here. So we're subtracting out, this should be set so the green is going into channel booleans, operation set to subtract, alpha's doing nothing. If you want this to be your defaults, just right click on the word, go to settings, save default. Then you're set up for the start of frequency separation from there moving forward. Your viewer should look black right now if you're doing subtract and you're doing this correctly. However, oh, did I just... No, I just moved that over on accident. What you want to do, though, to actually see the texture is gamma up. So now you can really start to see, oh, yeah, there's no texture there where we had done all that schmutzing with the edges. So we need to fill that in. You just do this now that we're on a texture layer with a paint node. So just grab a new paint node, and we sort of clone in from the sides where there's similar texture we want to use. I'm using stroke. Again, we've talked about this before. The third one across is uses modifiers, and it also paints across all frames, which is what we need. So I'll use the clone mode over here, and I'll use snap offset. Snap offset. Make sure you have no subpixel sampling between where you source where you click for your source and where you paint from. It just keeps things looking a little sharper. And I'll just increase my brush. So command drag out a little bit, and then option click pulls a source, and then you can just start painting in from either side, and I can paint on top of paint. So after you've laid a stroke down, you can just go right over it again. Maybe you don't want some of those extra splatters of dirt or whatever it is. You could sample a smaller brush, grab a paint from there, and let's say we want to remove that piece. There's also a faint bit of, looks like some of a double line of the trim down there, so maybe I need to get rid of some of that. Anyways, you get the idea. We painted texture to fill back on top of our diffuse layer. We just need to put the puzzles back together. This time we did subtract, so I need to do the opposite of subtract, which is add. So I'll take channel booleans, Command C, Command V, change this one to add, and the two that you add is you add this texture layer and you add this blurred copy. And now all we've done is taken that texture layer and paste it back over there. It's really hard to see with the viewer like that, but let's see if we gamma down and we can try to see some of the texture. Here's where we can sort of tweak the values of the texture to see, did we get enough? And I don't think we did, but our clones are good. All we need to do is adjust our blur, which is basically our blur is the amount of texture we're pulling across. Adjust your gamma to really try to see the difference between textured areas and non-textured. Command drag the number field over here to do it in fine increments till you're starting to see that some of that texture pop. And if you go too far, that's not good either. So it's always finding a fine balance. The value I have right now is 5.42. And again, if you're following along at home, you can use the same values. Footage is up on Cutting Club. I would call that pretty good. So that's going to hold up to any colorist grades that they may do further down without showing any artifacts or, any of the patch that's not working. That's kind of the point of using these magnifying glasses that I call that are the gain and gamma sliders, right? So we've got our diffused layer, we've got our texture layer all done. We just need to cut this patch out, and then we'll merge this over the stabilize and get it to move and add our grain. So let's do that. So this was our patch that we had previously done for the color layer. I'll just take that, a copy of it, sure, Command C, click, Command V, and this is now a new cutout that actually has the texture in there. You can see it's got all the lighting changes, very procedural method. Now all the complicated hard work of inpainting and retexturing is done. We just need to get this thing to move again, set it to the original canvas, and merge over the original. And then we'll talk about regraining, which is actually not that difficult at all to do either. So in lesson 1, if you recall, we stabilized using the planar tracker, right? We took a copy of this and we paste that copy of the planar tracker down here at the end of the flow, because this is what's going to allow us to reintroduce the movement to the patch. So all you do to reintroduce the original movement or match move again is click the box that says invert steady transform. We'll plug our patch directly into there, and you'll see right away we've got a moving patch that has the texture, that has the lighting changes. And then after that, we need to reset this into the original pixel coordinates of the original shot. And we did that with the second crop, which use negative offsets and setting the X and Y size to the original resolution. So that'll look something like this, following along nicely. And then we just merge this over the original denoise plate, which our original denoise plate is right up there. We come down here to our merge, load that into the flow, and we have successfully inpainted the shot on a denoise plate nonetheless. So next I want to talk about regraining using a couple different methods. Regraining actually means we're going to add the original grain, or in our case in this shot, because there wasn't a lot of grain, the original artifacts back on top of the full image to have affected it the least amount of possible. It's about preserving the original plate so that it can be dealt with in color correction however they want to deal with it, if they want to add their own grain and remove this, or at least restoring everything to how it was. That's the point. Now, to do that, we still need a copy of our original grainy version of the footage. This is the original, it was a ProRes clip that I started with before the denoise, and then we have our original, or not original, our denoised saver that we had done as well. And then, again, this was hard to see with our naked eye, so I encourage you to look at like the red, green, or blue channels to see the differences between these, and potentially even increase the gain and gamma sliders to give a little bit more contrast so you can see the actual difference between these. There is a difference. And the way we actually extract the grain pass only is frequency separation, which you are now familiar with, right? So we're going to grab a channel booleans to do that. And then we're going to use either subtract or divide. I think I'll do subtraction for grain is typically what I go for. So I'll grab another channel booleans, and we take what the original footage is, the grainy or artifacty footage, and then I take a copy of the denoised version, the one we've done our whole comp on, and that'll be subtracted, so that's going in the green foreground input of channel booleans. Load that in the viewer, and let's make sure your operation is set to subtract and do nothing on everything else on the alpha. Now, you can't see much in the viewer right now, but if you pump the gamma, yeah, you can see exactly what we've extracted here in this little pass here. Essentially, a denoise plate, as far as frequency separation, is kind of like the blur output when we do it to extract like the texture like we did in the previous step. Same idea here. The one thing that this can sometimes be an issue with, and I've got another solution for you after this, is you sometimes are extracting and pasting over original grain detail like we might see right here where the sticker was, which can be offset manually. I'm going to link to a tutorial where I teach you how to do that, because sometimes that's enough. Sometimes just adding this all back on is fine, but other times you need another tool, which is probably the main missing tool for professional compositing that Fusion does not have native, and I'll show you that in just a sec. But let's finish this out. We've got to subtract. What do we do after subtract? We want to add this back to the denoise comp. So we'll just I'll take a copy of that, bring it all the way down here. Let's see. Actually, you know what? Let's do it up here first. Command V. The second one's going to be add. And I'm going to take this add, and what I'm going to do is add just this grain all the way down here. You could use a wireless node, a wireless link node, so you don't have these super long pipes. And I'm taking the comp of everything. It's still looking at the blue channel. Let's go back to color channel C. We're going to take the comp, feed that into the channel booleans here, and now this is the final result of the regrain of everything. Let's gamma down a little bit, gain up, and it's restored everything originally to how the original footage was across the board. Now you'll see, yeah, I can kind of see a faint bit of detail from, the noise is actually different when you remove something, so I can sort of see some lines there. So like I said, there's a link that's going to take you to offsetting the original grain, but what I found to be a really good tool, and it is a little slower than this method I just showed you, but the results are amazing, is a macro from a guy named Emilio Sapia. He has a YouTube channel that's fantastic called Milo Lab Toots, or Tuts, whatever you want to call it, for tutorials, and it's called Grain Sync. I've got a little quick walkthrough on how it's used on my editing playbook channel, but in a nutshell, this is how simple it is to use. And essentially what it does is it uses a scatter method of the original grain to fill in just this patch that's right here. So basically we use the original grain everywhere, except in here, we use like a broken up, scattered up version of it, and it matches most things very seamlessly without any effort. So here is how that would work. I'll go ahead and just delete this setup, this subtract. Let's see. My grab link distance must be too close. delete that version of re-adding the grain. And this one is going to be the grain sync method. It's a macro. Like I said, you can get this from the, well, I don't know if I said it, but you can get it from the Steak Underwater website. It's the We Suck Less forums, or maybe it's the other way around. But either way, it's basically where all the really talented fusion artists live, and that's where I've picked up a lot of these tips over the years. And that's where you get it from. I'll put a link in the description. So shift space, and it's going to be called Grain Sync. This is very similar to what's called DOS Grain that people use in Nuke or in Flame. They have a tool that's built in called Match Grain. It's going to use a Voronoi pattern that's going to use a scatter function, and it uses this grain response curve to basically match the original grain to replace it. Let me just show you how it works. So it's got 3 main inputs. It's got a spot for your comp input, which is the main yellow input. It's got a green input, which is for your original grainy footage, and a pink input, which is your denoise plate. So I'll just plug it in. So it always starts with the yellow input. So just start with your comp, and then I need to pipe from the original and the denoise. So I'm going to grab my green, take that all the way up to the top. That's my noisy plate, my original plate. And then I've got my denoise plate. That's the pink one. That's the original denoise plate. Just the full resolution is what this should be working on. And if we take a look in the viewer, a couple things to point out the way the tool works. First is there's a selection box here. This is to basically sample a region on the frame that has no texture so we can create this grain response curve. Now, you want to make sure when you park it, let's say we do it, where's a darker frame? It's darker at the beginning. I'll probably start it there. So frame 1001. Once you get to a frame 1001, you take this box and place it on an area that doesn't have too much texture, you know, in the footage. So I'm trying to find, maybe right there is a decent spot. And then once you're on frame 1001, you go to the inspector, say set to current time. So click there, and then you say reference match. And this places an RGB curve, which is trying to get a sample of all that grain. Now, what the tool is doing as default, without any of this right now, is it's just adding back the original grain the exact same way I had done subtract and add, I believe at least. But where the benefit comes in is to get rid of this line that you can sort of see in there. Maybe if I emphasize the contrast, you can see that better. It's going to give me a scattered version of the grain instead. And so if I click on for scatter, and we take a look, you can see that has just taken a pattern and scattered out all of the grain. If you come over here, there's some QC modes. There's there, under that QC mode, it's giving you a different preview of what it looked like before and then after. So you can really sort of see this is done a rescattering, but it's rescattered the entire plate when you use this mode. So you do want to mask off just to the area that you did the replacement of. So then the rest of the plate stays as it was. So the way I will do that is just by pulling a mask of just our patch. Remember, at the output of this crop node, we actually have an alpha channel. The only thing about this is it's a soft matte. So if I look at the A for alpha channel, and this tool really, when you regrain, probably deserves a hard matte so you don't have a soft edge of like faint different levels of grain. So we're going to modify this just slightly with a bitmap tool to make that mask harder. So bitmap is a great tool to modify alpha channels and only output an alpha channel from it. So with this set, I'm just going to take the high value and choke that way down really far till it's pretty hard. Maybe something like that is plenty hard enough. I also have my gain gamma viewer sort of cranked over there. And so all you'll do then is in the grain sync, C for color, in the grain sync node, just drag that as an effect mask. So that'll go in the blue input. And now what we have is scattered grain in the middle of it, but everywhere else is the original grain. And that's kind of it. If you get any weird sort of artifacts and whatnot, you can change and move the pattern box of where it's sampling from. And you can get different results for sure by doing that. And you can also modify this grain response curve if there's like spikes. But that's basically all there is to that. I would say at this point, you could just render this out. So I I put a saver down here. And we can return our gain and gamma to normal levels. And on the saver node, I'll just go browse. I'll give it a render location, hit save, and then I'll go Fusion, render all savers. Let that cook. And then at least this is going to give you an idea how long it actually takes to render a shot. Even when we had denoised the original plate, it looks like it's going to take maybe 2 minutes or so to do this. What is it, like a 2 or 3 second shot or something? Which is typical. So a lot of times people say, I just want to paint something out really quick. This is not the really quick method. This is the correct method, the right method. And this is just one patch. You may have multiple patches on a typical commercial shot where you need to treat all of these individually. And you just sort of break them out into these little cropped regions. And work on and break bigger pieces off into smaller pieces. It's like someone always asks that thing, or is like, how do you eat an elephant? And it's one bite at a time. Or it's basically you break something that's really big into smaller chunks, and then it's just breaking out patches, sticking them all back together. And the great thing is Fusion can handle all this. It's been doing it for many, many years. I'll speed this part up here, and we'll take a final look in the edit page next. All right, the shot's done. It looks like it took about 1.5 minutes. I'll click OK. And then to make use of the saver that we just did is I need to load it in. So Shift Space LD, and it will, as I mentioned before, it pre-populates the last rendered file that you had done, which is awesome. And now you can play back as soon as it caches through the first time without having to wait for any of that complex math that we had done throughout the comp. You come over here, stick it to your media out. And the great thing about doing it this way, as soon as you come over to the edit page, you don't necessarily need to do a render in place or deal with cache on this page at all, because it's actually just reading directly from the saver loader that you had done prior on the Fusion page. So you've kind of nested the pre-render on the Fusion page, which I think is kind of a neat way of doing it. If you want to see the before, Shift D will turn that on and off, like so. And I'll just give you a quick recap of the overall comp here before we go. So back in the Fusion page, I'm going to go from top to bottom. Just an overall recap of the main steps. We've taken our original footage, we did a noise reduction on it. This was all in lesson 1. I set the threshold to 3, motion type to better, and I rendered it out with a saver and then a loader. And so we always worked on our denoise version of the footage. We cropped it to optimize the resolution. We planar tracked it. The planar tracking actually happened on a divided frequency separated layer to try to avoid any of the, or just basically just track the most detailed textures, you know? So we got a really solid track and changed it to steady. Then after that, we did smear paint was the one we went with for this video. Of course, there's other inpainting techniques we covered, like blur and then divide by the alpha channel, as well as clean plate. After we did some paint on it, we did a little directional blur to sort of make it a little bit more hidden what we've done, you know, clean up and average out our paint. Then we cut out the patch. That was done with a brightness and contrast with the settings tab set to multiply by mask. Okay. After that, I merged that over the original stabilized version of the plate. And if you were not worried about adding texture, at this point, you could just say, you know, skip this part and just match move this. But because we go the last, you know, extra 10% here on Creative Video Tips, we're going to continue on with the frequency separation layer, which is taking a merge of all this, doing a blur copy of it, and we did subtraction to separate the grain, or sorry, the texture only on this one. And if you bring up the gamma, you can really see there was a lot of texture that probably could be clone stamped across. And blurring a copy and subtracting it basically isolates those high frequency details. And we cloned on those. So that's the paint node right there. That's what happened there. After this, we added the texture clone offset with the original blur. And that basically restores everything as we would want. I'll reset our gamma there. Then we cut out our patch. The way the patch was cut out is exactly how we cut out the patch at this step. I'm using a brightness contrast with the settings set to multiply by mask because it's really, really efficient. And then we match move it, planar tracker set steady to invert steady transform. We repositioned it on the larger canvas, and then we merge it over the original denoise plate. After that's done, we regrain. And then just render it out, a saver, a loader, and then your editor or colorist will be amazed as you hit Shift D and realize how the heck did you do all of that professional nuke level, flame-like level compositing right in the Fusion page of DaVinci Resolve Studio 21. Thank you so much for joining me on this course. This is sort of an experiment to see how YouTube courses go. I'd love if you gave me some feedback down below in the comments to see if this was useful for you at all. Also know I'm available for training over Zoom. I do one-on-ones, and some months I have availability, sometimes I don't, but just reach out. I would love to help you out. And because there's so much more to learn, I'll see you in the next video.